Okie dokie. Lesson 21 still, but problems 31 to 60. And problem 60, I think I'm going to start a very quick explanation of getting started with a unit circle in trig. So I'm going to do some work around that. Again, the video introduction to the unit circle will go into it in more detail, but I'll do a little quick crash course in how to get up and running with radian measurements and the language of trig. All right, so in calculus, you might encounter a calculation like this, the integration of this calculation, and students have a lot of trouble with it, not because of the calculus, but because of the algebra. And so that's why this is a problem that I'm having you do on lesson sets. So that maybe if you end up having to integrate something like that, it won't throw you. So what do we multiply x minus 4 to get x minus 7x? Well, that's x minus 3. That times that gets us that. And now I've got that multiplication, all right? And that's minus 4 times minus 3. It gets us positive 12, and we want positive 3, so I really have to go down 9. And so x minus 4 times x minus 3 minus 9 is another way of saying x squared minus 7x plus 3. And putting a number in certainly helps us see if it's right or not. So if this is a calculation on the left and I put the number 4 in for x, it gets rid of the multiplication and it gets me negative 9. If these are indeed the same calculation, then over here, an x value of 4 has to get negative 9. Well, 4, 16 minus 28 plus 3 is 19 minus 28, which is negative 9. So I know this is correct. The only thing that I'm hoping you can see is that we can move that answer inside the parentheses as follows. X minus 4 minus 9 over x minus 4. Hopefully you can see, I meant to say 3. Here we go again. Not a great start. Talking and not looking. Hopefully you can see this, right? Gets us x squared minus 7x plus 12. That gets us x squared minus 7x plus 12. And 12 minus 9 is 3. But maybe if I do this, you can see why I can write minus 9 here, because x minus 4 cancels, and that gets us the x minus 9. All right, so that one's done. So number 31, x minus 3 minus 9 over x minus 4, I believe is what I said before. So 32, 4 plus 5i, 4 minus 5i. We're always going to get a negative I squared. And a negative I squared is going to become a positive 1 times the coefficient, right? It's going to change the sign of the coefficient. So the denominator right now is going to be 16 minus 25i squared. And obviously that becomes positive 25. So we're going to end up with 41 in the denominator. And that's always going to be a negative, which means that I could go back here and simply square 4, square 5, add them up. And I'm going to get that in the denominator. Just a little shortcut. All right, numerator. 4 minus 5i. I'll put that in parentheses now. That gets us 8. If you want to do the, well, no, I'll just keep going. 2 times negative 5, negative 10i. Minus 3i times 4, minus 12i. And minus times a minus is a positive 15i squared. Now, what is 15i squared? It's minus 15 plus 8 is minus 7. And minus 10i minus 12i is minus 22i. So that's problem number 32. Solving this, well, gotta let your mechanics carry the day. So the exponent on top of x is a 2, and that's going to get us the quantity x plus 2. Well, now we're back to algebra 1. x2 minus x minus 2 equals 0. X minus 2 times x plus 1 equals 0. X could equal 2 or negative 1. Unfortunately, the base of exponentials cannot be negative. I don't know why I said unfortunately, it's just a rule. So the only answer here is x equals 2. So let's see if that's true. 2, 2. 2 plus 2 is 4, and I think 2 squared is 4. Sure looks like it works. And I don't think there was anything that we did here that is different than what we've done. I know it's the first time you've seen a variable equation like that with logarithms, but just follow the mechanics. Seemed like it was doable. 34. Cube root of 64, I know is 4. I'll take that. And the cube root of x to the 9, I know is x to the 3. And I know I'm still working with a cube root, so I'm going to write a 3 there. And that takes care of everything except y to the 7th. And the cube root of y to the 7th is the cube root of y to the 6th times y. And I know the cube root of y to the 6th is y squared, and I've run out of room here. So let's bring this over here. 4x cubed, y squared, and y squared cubed is y to the 6th, and I need another y to get to y to the 7th. All right, Renee, let's keep moving on here. Let's go. Moving on down the line. Sounds like a Johnny Cash song. F of x equals x cubed plus 6x squared. Your worksheet might have a 12 here, but I'm changing it to a 6 just to make the numbers a little simpler. All right, so minus b over 3a. Minus b. Minus 6. 3 times 1 tells me that the point of inflection occurs at x equals -2. Now, all I have to do is do f of -2. And I'll do that above. So f of -2 gets me -8. Without looking, I better get 24 next because it's a 3-to-1 ratio. And when I put those numbers together, I get -16. Okay, there are shortcuts here. All right, so plus 10 times -2 is -20. Minus 5. All right, minus 41. It doesn't hurt to start to think about what this looks like. So I know 0 gets me -5. I know -2 gets me -41. I also know that I'm going up at 10-to-1 right here. And then it sure looks like it bends down, back up again. We'll be studying this in more detail after midterm, but that much we know from what we've already talked about. Remember, that's always for polynomials, the tangent line to the y-intercept. And we've looked at y numerous times, and I'm guessing those conversations probably haven't resonated yet, which means we probably have to have that conversation lots more times. And that conversation was based on dropping a 0 in and then dropping 0.001 in and getting the change in y or the change in x. And it sure came out to be 10-to-1 rate of change. Planting some seeds here, perhaps, but it would be nice if you already understood that. 2x plus 1 square root function whose x-intercept is -1/2 gets me a 0, and it slowly goes up to the right. X minus 1, well, that might be -1. Sure looks like there's one point of intersection and only one point of intersection. So let's get that one answer. Square both sides. 2x plus 1. Hopefully you square this properly. X squared minus 2x plus 1. Set it to 0. I got x squared minus 4x. Oh, looks like the ones cancel. I think I can factor that x times x minus 4. And the only answer we have is x equals 4. 0 will not work. If I plug in a 0, I get the square root of 1 equals -1. Sorry, not true. But if I put a 4 in, I get the square root of 9 equals 3. Yeah, that looks good. So that was the answer to 35. We just got an answer to 36 of x equals 4. We can get rid of this. We can get rid of this. We can get rid of that. All right, so this answer, maybe you can get to the point where you can just say x squared minus 8x, 16 and 4 square root of 20. Or I don't need to say that, just plus 20. So that's where we're hoping to see. How do I know it's minus 8? Because the 4 has got to come to the other side. I know I'm going to square, so that becomes 4i squared. If I square that, I get x squared minus 8x plus 16. And 4i squared is negative 4. When I bring it over to the other side, it's positive 20. All right, so that's done. Let me complete the square on this real quick, even though it's factorable, right? 10 and 2, but let's do completing the square. So that's x minus 4 squared minus 16 plus 20 equals 0. That's positive 4 on this side. It's negative 4 on that side. Squaring becomes plus minus square rooting. There's your plus minus 2i. And negative 4 becomes positive 4. And I believe that's what we started with. Okay. We want to be able to go forwards and backwards with those problems with ease. And the only way something gets easy is if you do it a lot. Just remember what it was like to tie your shoes the first time. I bet you've tied a lot of shoes since then. And I hope it's not hard. All right, so we need to solve for x. We got 149, so this is 51 units of area. So x is the square root of 51, and that's the adjacent side to the angle, divided by 10. Done a bunch of those. Y equals 5 is the asymptote. Exponential problem. So how do you get from 5 to 20? You add 15. Next time you don't add 15. How do you get from 5 to 35? You go up 30. So I got an exponential decay. X 2000 minus 2000 divided by 2000 to 2024, 24 years of time have elapsed. That's just the mechanics. You want to understand how it works? Drop 2000 in, watch the numbers materialize, and drop 2024 in. And you'll see these data points emerge. All right, so that's 39. I guess the answer is there. I'll leave that one. I'll leave the answer right there. F of x as a piecewise function. As a piecewise function. Boom, boom. Alfred Hitchcock. Put a little I. No, I can't put an I there. This is an absolute value with a V shape up, which means the left side is decreasing, the right side is increasing. Decreasing will have a slope of -2. Parentheses, x minus 1, that's where it hinges at x equals 1, plus 3, and I'm on the left side of 1. Positive 2, x minus 1 plus 3 for the right side of 1. And it doesn't matter where the equal sign goes, but it does exist. The vertex of this does exist, 1, 3. And remember, x minus 1, just a linear function. What happens when I slap an absolute value? The y values become positive. That's why it hinges at 1, and that's why I'm showing you where it hinges. Now, how do we make this thing equal to 21? All right, well, that's a y value. First step is what? Subtract 3, divide by 2, plus minus 9 from 1. It's really what I'm doing. I'm moving 9 units from 1, which gets me 10 and also -8. So those are the places on the number line where I hit a height of 21. I hit a height of 21 at -8 and at 10. And what's in between -8 and 10? Well, that's an average. And that's 2 divided by 2, which is 1. Oh, yeah, 1. Equidistant, 9 units. Now, what happens if I put a little dash here? Dash, because I'm going to be doing dashes and dots in a minute when we do inequalities. Doesn't mean anything to you yet. But when am I bigger than 21? That was another question. So number 40 was, the answers to number 40 were x could equal -8 or 10, that will get me 21. And now, when am I bigger than 21? Well, let's actually put some numbers bigger than 10 in and see if this interval, is this interval for x values greater than 10 going to work? Well, I think any old number will do. Why don't we plug in 100? Well, that's 2 times 99 plus 3. Is that bigger than 21? I think it's true. Let's put a 0 in. That's going to get me 2 plus 3. Is that bigger than 21? I think that's false. Now, 21 is here, by the way, right? And if I get rid of this branch and that branch right there, then I'm getting rid of that. And we just said that's true and this is false. I got a feeling that's going to be true. Let's put minus 100 in here. Well, that's 2 times 101. Minus 100 minus 1 is minus 101. And what's the answer value minus 101? 101. I think it's true. And we're trying to learn interval notation. So where does this go? Positive infinity. Where does this go? Negative infinity. I think the interval negative infinity, which I wrote as the 8, negative infinity to negative 8 works. And so does 10 to infinity. Now, what if instead of greater than I had greater than or equal to? Well, then I'm going to change negative 8 to something that actually works by showing a bracket. And that basically is a closed circle in this direction. And then 10 works, and that's a bracket. Okay, probably we'll do that more after midterm because we're just, getting up and running here. 43. At this stage, you should be thinking inverse operations. And how do you evaluate a function? Hard to easy. So therefore, how do you solve? Easy to hard. What's the easiest operation up here? 4. If I put a number in, I do the parentheses, ln, multiplication, then add 4. I'm going backwards. I'll subtract 4. I'll divide by 5. I'll do the inverse of ln of is e to the, and that's the. That's the exponent. And then plus 3. E squared plus 3. So that's problem 43. E squared plus 3. It doesn't hurt to see how it works. 5 ln of e squared plus 3 minus 3 plus 4. I can see the 3's cancel. What's the exponent I put on top of e to get e squared? What's in the parentheses? I hope you say 2. I'm looking for exponential activity on top of e. Well, there it is. So that becomes the number 2. 5 times 2 is 10 plus 4 is, oh, thank goodness. No careless error there yet. But they're coming. I'm sure those careless errors are coming. So what do I have to do with a 9? I got to take a square root to make it a 3. I got to cube it to make it a 27. And in order to put it in the denominator, I need a minus sign. All right, so that's that answer. Now the question is, I want to have these answers over here. So that was e squared plus 3. In case somebody's shortcutting this and just doing the 5 problems. This one is minus 3/2. Showing why that works. 9 to what exponent? Let's make this an x. Let's say we don't know what it is. But 9 to the x equals 1 over 27. 9 is 3 squared, so I could write 3 to the 2x. 27 is 3 to the minus 3. And 2x equals minus 3. Hence, the answer, minus 3/2. Square root, cubing, reciprocating. Okay, so that's out of the way. This is out of the way. 45. I want the cube root of 64. That's what that operation is, which happens to be 4. And then I'm going to square the 4, which happens to be 16. I put an arrow there. It's not a negative 16. And then I got to put it in the denominator. That's really what you're doing with that. Now, you could do it in a different order. You could square 64 and take a cube root. You'd get 16. That seems a little harder to see. So go small, then big. So 45, 1/16. 46. Same basic topic. 16 is 4 to the 2. Oh, I got a base 2 problem, sorry. Base 2, 2 to the 4x is 16 to the x. 8 is 2 to the 3 times 2x minus 4. Now we have the bases the same. Therefore, 4x has to equal 6x minus 12. I'll bring the 4x that way, make it 2x. I'll bring the 12 this way. And now I can see x equals 6 as an answer. All right, difference of 2 cubes. And if you were doing the lesson set as a test, and it was going to be Friday's test, I decided to give it to you as a worksheet for tomorrow. Been 20 minutes probably since you did the last putting cubics in factored form. So let's see if you remember what to do. Cube root of 64, 4. Cube root of 8 to the 9th, 8 to the 3. Cube root of 125, 5. I got to have a minus 5. Let's get that a little closer. Give me a little more room. M to the 3. Okay, we're done looking at that. Everything comes from these two numbers now. I got to square that one to get back to a cubic. So that has a side length of length times width. This is width. This is length. I need width times height. I need to square that. 16a to the 6th. To get the cancellation, a minus means I need a plus over here. 4 times 5 is 20. A cubed, m cubed. And then I got to square this, which means it's always positive. I don't care if that's negative or positive. When I square it, it's positive. 25 m to the 6th. Oh, I'm sorry. I thought I had a 9 there. This is just m, and so that's m squared. Too close to it. There. Now I'm further away. You're banging the head. All right. F of x equals 2 e to the x minus 4. Of course, I moved the answer key, but I had the marker and the eraser, and I got Rene, so that's improvement 3 out of 4. I'm assuming this is probably f minus 1 of x. What's the inverse? That's the question I'm doing now. Put a number in, subtract 4, do e to the multiply by 2. What was the last thing I said? Multiply by 2. It's the first thing I'll do over here. That means I'm doing, put a number in, subtract 4, and do e to the. I got to do the inverse of e to the. Maybe you're hearing a familiar refrain, ln of. And then minus 4 becomes plus 4. What's the easiest number to plug in? I like 5.1 here. Gives me e to the 1.1. 3 times 2 gets me 6. I can see a 5.1 gets me approximately 6. Therefore, a 6 should approximately get me 5.1. 6 divided by 2 is 3. The ln of 3 is 1.1 plus 4, 5.1. There's the inverse. Move on. All right, I forgot to put problems over there, but that's all right. That was 47. F minus 1 of x is 48. Clean it up a little bit so that if somebody is moving around in the video, might help a little bit. So what do I see here? I see a critical number of 6 for y. 6 minus 6 is 0. I can ignore that by using the number 6 for y. So then I need something divided by 100 that gets me 1. That better be 100. And if I'm squaring something, I think it better be 10 or negative 10. What makes this 10? 15. What makes this negative 10? Minus 5. Is that any different than how we graph 2x plus 3y equals 12? No, we make zeros so that I can see 6, 0 is the x-intercept, so on and so forth. It's the same concept. Yes, it's a little harder, but you're trying to get those smooth pathways. So you want to make connections. Oh, how does this problem relate to some other problem? How does this relate? It relates to that. And in future work, you're going to see that you got a graph that looks like that with linear asymptotic behavior, planting a seed. It's called an hyperbola. All right. so that one's done. All right, so we're just gonna solve this. So I'm gonna subtract 5, boom, 2. I'm gonna divide by 4, boom, 1/2. 2 to the, what's the inverse of 2 to the? Log base 2 of. That's a standalone question we've been doing since day 1 in this class. I hope you know that's -1. And now I have x minus 3 equals -1. I'm gonna add 3, and I'm gonna get 2. Let's check this out. 2 minus 3, -1. 2 to the -1/2. 1/2 of 4, 2, plus 5 is 7. I like the answer. So that must have been 49, and the answer was 2. Feel like I missed a problem here. All right, moving right along. Just on the simplest level, we want to get t equal to something. And we better get it out of the denominator by moving it into the numerator. And then I think all we got to do is multiplication by 8, divide by 8, and 51 is 7/8. ln of 9/2. This is where our rules of logarithms are going to be. And that's going to be 2 ln of 3 minus ln of 2. That's using the rules of logs. Now, how are we going to get there? You got to have some things memorized. You absolutely need to know what ln of 3 is and what ln of 2 is, or don't bother doing this problem. Okay, so what is 9/2? 9/2 is equal to 3 squared over 2. What's the new name for 3? E to 1.1. And you're squaring it. And you're dividing by e to the 0.7. That gets us 2. All right, I think that is equal to e to the 2 times 1.1 minus 0.7. I think that's 2 ln 3 minus ln 2. Interesting. So I guess that means if I was using the rules of logarithms, which I guess we're starting to talk about, won't be on your, I'm not asking you to do that on your test. I am asking you to do this. I am asking you to get 2.2 minus 0.7, 1.5. And we got a bunch of people who can do that now in 5 seconds or less. Okay, I'd like everybody to be able to. But how would I do this? Well, division implies a subtraction. I didn't show it. 2 ln of 3 minus ln of 2. There's a subtraction because we have a division problem. So, ln of 9 minus ln of 2. And that's the exponents in the numerator, which were here, e to the 1.1. I'm dealing with the exponential activity in the numerator minus the exponential in the denominator. Wouldn't that be something similar to this? Wouldn't you say 2 times 7 minus 5? And if you're working with exponents, what's another name for an exponent? Logs. So we're really highlighting the exponential activity. And 9 is the ln of 3 squared. And so whatever exponent comes out of changing this into e notation is getting doubled. So I could move it here. All right, and that's our first conversation. It's one of our earliest conversations on the rules of logarithms, which are really fancy terms for rules of exponents. So that was 1.5. All right, so I'm going to start doing those a little bit every day for the rest of the year. Oh, ln of e squared times e. All right, so what is this asking? We don't write e, and we don't put an x on it, but we're trying to figure out e to the x equals e squared times e. By God, I hope you say 3. Right, because that's a 1. Add up the exponents. That's your answer. If you do e cubed, if you put that 3 on top of e, I think you're going to get an equivalent statement that e cubed is e squared times e. I would say yes. Come on, Renee. Let's make the corner here. All right. Let's get this chair out of the way. Should have moved this stuff to begin with. All right. Remember, a to the minus 8 is equal to 1 over a to the 8. And what used to be in the numerator is now in the denominator with a change sign. 1 over a to the minus 8 is 1 divided by 1 over a to the 8. When you divide by a fraction, you multiply by the reciprocal, and now it's in the numerator as a positive exponent, not a negative. I guess I can move negative exponents in the numerator and make them positive in the denominator, and I can move negative exponents in the denominator and move them into the numerator. So therefore, 9 over 15, 3 goes into 9, 3 times, 3 goes into 15, 5. 8 of them are going to be down in the denominator now, and these 5 are going to be in the numerator. And this minus 7 is going to be in the numerator, and that's already in the numerator. I'm not going to move it. Final answer, 3b, 4 and 7, 11 over 5 and 8. There's 3 more in the denominator. That's that answer. 56. Y-intercept for f of x. I hope you don't say 4, because you got to plug 0 in and do the math, which is 15. 3 to the negative 1 plus 4, which is 15 times 1/3 plus 4. Sure looks like 0 gets me 9. Square root. Hope you can just look at it and say, oh, it starts at negative 2. I'll write x plus 2. Drop negative 2 in, you get the square root of 0, which is 0. I don't want 0. I want 9. Write 9. Now, when I drop 5 in, my second x, I get, I don't know what you get. You might say 7. I think you get the square root of 7 plus 9. And we all know that equals negative 8. So I guess I'm done. Oh, no, it doesn't equal negative 8? Oh, well, then let's make it equal negative 8 by getting rid of what doesn't work. And let's bring in what does. Yep. So what's the change? The change is square root change, and that's the square root of 7. What's the change we want from 9 to negative 8? Negative 17. And if you're starting to see it, it's a 5-second question. 72. I know 72 is 36 times 2. And I know the square root of 36 is 6. I'll leave the square root of 2 over here. X to the 4th, the square root of x to the 4th. I think I can divide 4 by 2. I think I got to leave the y inside. I think I can divide 19 by 2. That gets me to 18. That gets me to 19. That's your answer. The most important y value on the board is 10. And I'm going to read from left to right. That's my next y value from left to right. And from 10 to 24, it's 14 units. But then I got another y value of 17, and I know that's not 14 units change. 10 to 17 is 7. Looks like that's about half of that. And I think that's going to be half of that. And that's going to be, if I drew it better, half of that. And it looks like I'm headed towards asymptotic behavior here. I think my y values, the limit of this function, as my x's go to infinity, but I'll write big. The bigger the x, the closer I am to 10. 24, 17, 13.5. Well, that would be this one, 13.5. 3.5 cut in half, 1.75, I believe. And 1.75 is 11.75. 11.75. Can you see the trend? I think I'm heading to 10. Cutting that distance in half every time. All right, now I'm going to do the trig. Going to give a real brief introduction to the unit circle. Very brief. Again, looking at the intro to the unit circle video, probably in the trig playlist, intro to the unit circle. Highly recommend seeing that. And also, what is a radian? Which is what high school students have a big time problem with that. Okay, lights take a long time for that to go on. I'm going to start with an equilateral triangle. 60 degrees, 60 degrees, 60 degrees. I'm going to cut it in half. And each side length is going to be 1, 1, 1. Okay, so I'm going to cut it in half. That gives me a right angle. And now that's 30 degrees, which I could have put on its side. 30 degrees. Still 1 for a hypotenuse. This has height and width. What's the width? Well, it used to be 1 across, and now it's a half. Pythagoras says that that's a quarter. That's going to be 1. Well, then this has to be 3/4. Has to be that. If I take the square root, I get √3/2. What's opposite 30 degrees if the hypotenuse is a half? A half. What's the width? √3/2. What's the angle? 30 degrees, 60 degrees. But I could have used the circumference of the circle as a measurement for angle as well. And what is 60 degrees? 60 degrees is that triangle. And if the radius is 1, there's your 1/2. There's your √3/2. And how many 60-degree angles are there? Looks like I won't show those this time. Okay, just looking at the top half, 0 degrees to 180. How many 60-degree triangles can I draw? Well, there's 60, 60, 60, right? And what is 60 degrees in radians? Well, in radians, this is 3.14 radius lengths, whatever that length is. 3.4 takes me to here. So this is actually pi/3, 180 divided by 360. This is 2 pi/3. And if I wanted the sine of 2 pi/3, 2 pi/3, then I got to do the counting, drop a perpendicular. That's a 60-degree reference angle. Then I know that is √3/2. And this is -1/2 because we're going to start putting this in a coordinate system. Boy, that was a crash course. And the cosine of 2 pi/3 is the adjacent side divided by the hypotenuse, which is -1/2, positive √3/2, so on and so forth. Okay, so now we're looking at this problem over here. Let's get a little parallel parking for Renee. Sorry, Renee, I'm pulling on your tires. All right. So this has been something we've been looking at for a while. I think I just did that conversation I wanted to have with you. So I can erase this. So what am I seeing? I'm seeing I'm at the top of the circle. Where is the top of the circle? If I break pi up into 2 parts, well, then that's pi/2 radius lengths, approximately 1.57, whatever the radius is. Okay, but we're calling the radius 1. So I can't draw the triangle, but it has height. The height is 1 and the width is 0. Keep that in mind. Well, I'm at the maximum height here of the circle. So why don't I build this model off of pi/2? Because I think I can see the height at pi/2 is 1. And that's where I'm at. And I know if I go around the circle, 1 time around the circle, I come right back to a max. So this must be once around the circle, and I know the circle circumference is 2 pi r, and if I make the radius 1, then it's 2 pi units all the way around, which means that's 1 pi, 2 pi, 3 pi, 4 pi, 5 pi. And sine does not work well with the number 1955, because that looks like a year, and I want it to act like an angle. So if I unwind the circumference of the circle, then I'm going to get something that starts at pi/2. That's where I'm going to start my analysis. And then if I add 2 pi, then that's going to become 4 pi/2 plus pi is 5 pi/2. And another 4 pi/2 is 9 pi/2. And another 4 is 13 pi/2. All these are maxes. There's my first max. There's my second max. There's my third max. And there's my fourth. And I don't have to go that far. So I want to be in between those, which is 11 pi/2. Now, how far is it from pi/2 to 11 pi/2? 10 pi/2, which we said is 5 pi. So the period of this is Well, let's not go there. There's enough on your plate to begin with. But how can you write this function very quickly and easily? Well, you got to start with the midline. That's where you're measuring from. There's an amplitude here, right? And the midline, normally on the sine function, is 0. The sine function goes up, down, up, down, up, down, up, down. We start with a midline of 0. We get to a height of 1. We get to a height of -1. So the range of the sine and cosine function is 1 and -1. But we're going up to 100, down to 40. So we're not in the middle, 0. We're in the middle of 70. Okay, so this now becomes the number 70. And I'm not going up 1 unit. I'm going from 70 to 100. I'm going up 30 units. So that was a test question. What's the range of this function? Y values are less than or equal to 100, greater than or equal to 40. That's the range. All right, so now let's actually write the equation. And we'll be picking up on this after midterm quite a bit. So I see 70, I see plus 30. I'm going to do a sine function. I know I've got 2.5 revolutions of change. It always takes to do that 55, 45, and 247 units of years. I'm going to make a 0. I'm going to make 1955 into pi over 2, excuse me. 1955. And I want it to act like that location on the circle. So if I put 1955, that becomes 0. That becomes pi over 2. What's the height of pi over 2? 1. 1 times 30 is 30, plus 70 is 100. And then if I go 5 pi, I go 1 pi, 2 pi, 3 pi, 4 pi, 5 pi from this location. 5 pi from that location takes me to the bottom of the circle, which is -1 for a height. -1 times 30 is -30, plus 7 is 40. Now, where is there a maximum cosine value? Well, cosine measures width. And that width is 1, and this width over here is -1. And that's 0. If I start walking around the circumference of the circle, I start my journey from here. So the only thing that's different in this problem is I would say for cosine, 70 plus 30, cosine, this doesn't change by pi over 47. That doesn't change. 1955, I'm still starting at 1955. But I'm at a different location. I'll write 0. I don't have to, but I'll write 0. And I don't know how much of that I was blocking because this is close here. So I apologize for that. If a lot of what I was writing was blocked, well, we're going to keep doing it. And I don't think I'm going to make the video again because I've been here a long time and I still have another one to make. And so that people can use this as a study guide for the test that's coming their way in 2 days. And I hope that if you're at home trying to do these problems, that you get some practice and maybe not as much practice as an in-class experience, but enough to maybe move up the ladder. Well, that's the hope, and that's one of the reasons I'm doing this. But mostly it started out as okay, we're Zooming and we're doing things during COVID and trying to get some information out there. So still doing it. All right, stay safe and warm, as Yasser would say. All right, and I will upload this just a few minutes.